Good morning, dear students. Today we discuss impact testing of material. Impact testing is done basically to evaluate the toughness of material. Toughness is very important property of materials. It can be distinguished very easily with strength, hardness. See, strength is a property of a material to bear the load. It only take care of the load taken by the material. Whereas hardness is a very different property. It shows the ability to resist the scratch, abrasion, and deformation of a material. Whereas toughness, toughness can be distinguished from both hardness and strength. It is the ability of material to absorb the energy when it is impact fully loaded. Impact fully loaded means it the loading is sudden or at a perpendicular in direction. So toughness is more or less is the ability of a material to absorb energy. We take the example of glass and steel. Glass is a harder material, but not tougher. You drop it from some height, it breaks easily, but steel doesn't break so easily because it absorbs the energy of the impact. So when we uh, drop anything, there is a impact energy because the material comes to a rest at a sudden, so the energy evolved is dissipated in the material. So toughness basically deals with the energy, whereas strength deals with the strength. So when we take property of toughness according to stress strain diagram, see, when we talk about the strength, the ultimate tensile strength UTS, upper part of the stress strain curve, gives the ultimate tensile strength. That is the strength. It is the load bearing ability of a material. Whereas when we talk about the toughness, toughness is the area under that stress strain curve. So you can see that the area is colored one. That area denotes or indicates the toughness of a material. So more the area, more the toughness. So if we can see that brittle materials like ceramics for have a better idea about the ceramics, you can from our kitchen you can take a example of a teacup. It's made up of ceramic. It can break very easily. It is having a very low toughness. So low toughness, the area is very limited. When we talk about the steel or any metallic component or material, it has more area under curve means more toughness. It is directly related to the area. So when we talk about the toughness, it deals with the energy, and it is a balanced combination of strength and ductility. So if a material is having good strength and ductility, then it is also having a good toughness. Because area under curve is more, if strength is more, ductility is more, then definitely area under stress strain curve is more. So toughness basically a material property which depicts or indicates that material is having good strength and good ductility. So if you say that it's a particular material is having a good toughness, that means it is having a good strength and ductility combination. So for testing the impact properties of toughness, impact testing is done, and impact testing mechanism is very simple. In this, a pendulum hammer is strike on a material to be tested, and the amount of remaining energy gives the idea of the energy absorbed by the material. See, when pendulum is raised to a certain height, it possesses a potential energy, and when it drops suddenly, its potential energy is converted into kinetic energy, and it strike a sample during its motion. So some amount of energy is absorbed by the material, and that amount can be easily calculated. What amount of the energy that material absorbs before breaking. So that gives the idea of the toughness or impact energy or the material's strength of impact strength. So in next slide, we will discuss the mechanism, how the pendulum goes on. And two types of tests are basically done. One is IJOT test and one is Charpit test. A notch is provided. You can see the notch is there to break easily material. A notch is there in a sample so that the material can break easily. If material doesn't break, it does not give any idea about the toughness, what the toughness is. So we need a notch is there, so that will. So this is the some schematic diagram of the impact testing machine. Scale gives the energy of the this pendulum hammer. You see, when we raise a pendulum to a certain height, a stopper is there that stops the pendulum to a certain height. So it's suppose it stops at height h1, it is having certain potential energy. When it moves down and follows its path, it encounters with a specimen which is firmly fixed here. So its potential energy is converted into kinetic energy, but due to the energy conservation law, energy remains same. When it strikes to the sample here, it breaks and it consumes some amount of energy, and that energy can be easily calculated because when it passes the sample after breaking it, the remnant energy is left over in the pendulum, and it can be calculated by the height which is rise. So it suppose it starts from a height h1, and after breaking the sample it reaches to a height h2. So the remaining energy gives the idea of the energy absorbed by the material. So this is what the whole impact testing procedure is there. Thank you for watching. Thank you very much.